Welcome to the class. Myself Professor D.S. Rai, Professor Department of Civil Engineering, BBD ITM, Lucknow. In this lecture, we will discuss KCE 602 Transportation Engineering, in which we will take up lecture number 29, in which we will discuss design of bituminous paving mixes. The reference book that I have taken, that is the Highway Engineering by Khanna and Jesto, Principle of Transportation Engineering by Partho Chakravarti and Animet Das, Pavement Design by R. Srinivas Kumar, Building Materials by Dr. S. K. Duggal. The contents of this lecture will be mixed design. Mixed design consists of proportioning, factor affecting mixed design, FHWA 0.45 power gradation curve, proportioning of mineral aggregate, volumetric analysis of bituminous mix, Marshall mix method. So, these topics we will cover in this lecture. So, now design of paving mix means the material mixed with the bitumen. So, here we will discuss the materials which will give the maximum density. So, in the mixed design, our goal will be optimum quantity of bitumen, because it is a costlier material. So, without affecting the strength of the mixes, the quantity of bitumen should be minimum, means optimum quantity of bitumen should be used while mixing the aggregates. Hold the mineral aggregate together, because the quantity of bitumen should be minimum, but it should not behave like that the aggregates, mineral aggregates are not properly bind with the bitumen. So, it holds the mineral aggregate together. The third is the compacted layer providing the maximum strength. So, this is the main goal of our mixed design. The paving mix finally compacted will have a maximum strength to resist the deformation and durability. Not only the strength is important in this case, but the compacted surface should resist deformation, and of course, durability is the most important factor. Now, mixed design consists of proportioning of bitumen, coarse aggregate, fine aggregate, filler, air voids and admixture if necessary. As we have discussed, the bitumen is a costlier material. So, there should be a optimum utilization of the bitumen. Coarse aggregate, fine aggregate and filler materials should be mixed in such a proportion that will give the maximum density. And of course, if there will be the maximum density, the voids in this mixed aggregate will be lesser. But it is not like that the complete void should be removed. There should be some voids in the mix also. Air void and admixture, as I have told you that there should be some air voids in the mixes. Why it is necessary? Because due to rise in temperature or fall in temperature, the volume of the aggregate below the surface will increase, and of course, the volume will increase. So, for the adjustment of a small variation in the volume, that could be met out by the air voids present in the mix. And of course, admixture will make the mix workable. Admixture, of course, if necessary, then we will add it. The factor affecting mix design: stability, durability, workability. So, three basic things are here to decide the mix design. Then a stress strain relationship means our compacted mix will hold good as a stress and a strain will be a straight line like this way. So, this is the straight portion. So, our up to elastic limit, the permanent deformation, this should be avoided, otherwise our pavement will be will not work properly. Fatigue and low temperature racking. The major failure of the pavement system is due to fatigue, and at low temperature the pavement surface will cracks. Imperviousness. Our surface should be impervious. As we know, water is the enemy of the pavement system, either flexible pavement or the rigid pavement. But most affected pavement system is flexible pavement. If there is a stripping between the bitumen due to water, and this is the major factors in our country, especially in the rainfall prone area. Crore and crores rupees we are spending just to recoup the surface just after the rainy season. If water percolates inside the pavement surface, then finally there will be some deformation in the bottom layer, means subgrade, subbase, base, and of course, the wearing surface. In rigid pavement, if water percolates inside underneath of the pavement surface, then there will be a pumping action, and water, when load is coming on the pavement system, the water will pump out from the joints. As the vehicle go away from the spot, then the water will again go inside the pavement system. So, our pavement should be impervious. Susceptibility to moisture. A small quantity of moisture will make the surface failure. So, as far as possible, the moisture should be avoided by any cost, and this is susceptibility in the hilly area, where temperature goes below 0 degree and the moisture will convert in the ice ball, a small ice, which increase the volume of the ice, and finally it break the surface to adjust its increased volume. Cost effectiveness, this is the most important parameter. Without affecting the strength, life, and riding quality, the cost of construction should be lesser. Now, design of paving mix. and this consists of desirable property of the bitumen mix, physical requirement, the maximum size of the aggregate, gradation, the maximum density could be find out by the Fuller's equation P is equal to a small d by capital D to the power n. Here P is the percentage passing through a sieve in percentage, D is the size of sieve consolidation in mm, and D capital D is the maximum sieve size used in a given sieve set in millimeter. N is the adjustment parameter of the density curve for a maximum density. The n should be 0.5. So, by Fuller's equation we can calculate the proportioning of each type of aggregate to get the maximum density. Then the second is FHWA 0.45 power gradation curve. The maximum density curve represented by a diagonal straight line. This is the diagonal straight line in this curve, connecting points between the percent passing of the maximum size of the aggregate to theoretical 0% passing of 0 size of sieve opening. So, see here the unit of x axis consists of value of opening of sieve size raised, and here the percentage passing. So, by this way we can calculate the quantity or proportion which will finally give the maximum density. Proportioning of mineral aggregates, these are the different methods to just get the maximum density of the mixed aggregate. Proportioning of mineral aggregate, to get the desired density of the mix, the optimum utilization of available material by blending it into suitable proportion is necessary. So, there is a trial and error. There are different method of proportioning. One is the graphical method, in which triangular chart method and Roth-Fach method. This is the graphical method. This is using formula P is equal to capital A into A plus capital B into B plus capital C into C plus capital D into D and so on. So, this is a big equation, and that could be only solved by the computer, of course, because there are many materials available for the mixing. The third is the iteration method, means first is a trial and error method, simple iteration method or genetic algorithm based. These are the method, and generally we do this work by trial and error method based on experience. So, what happened? We just take some portion of coarse aggregate of different size, fine aggregate of different size, feeder materials, banding materials all together, and then we calculate the density. Now, change the proportion, and so on we can change the proportion and finally finding the density of the mix. The maximum density achieved by some proportion of the aggregate, that material could be taken as a mix for the mixing of bitumen. So, this is the graphical method, triangular chart method. Exactly three material types. Rothbard's method, this is the equation that we have already discussed. Here P is the percent passing of combined different of aggregate A plus B plus C plus D. This A, B, C, D is the percent of different type of aggregate passing through a given set of ships, and this is A, B, C, D is the contribution or proportion of different type of the aggregate in decimal. So, the summation of this all proportion will be equal to 1. So, if there will be change in say B, then suppose the B is increasing, then you have to decrease the C, means the summation of this all will be equal to 1. Now, design of paving mix, and this is the volumetric analysis of bituminous mix. So, here volumetric analysis of bituminous mix, density and voids present in the mineral aggregate and compacted bituminous mix are important volumetric parameters that decide the performance of bituminous pavement. The bituminous mix of high density are undesirable because there will be no room for expansion, that I have discussed with you, no room for expansion or internal adjustment of the constituent during the temperature changes. It is desirable before preparing a bituminous mix. So, now come to the analysis. Weight, that will be volume multiplied by the specific gravity. Now, bulk specific gravity of the combined aggregate means G bulk aggregate, and that will be equal to P 1 plus P 2 plus P 3 divided by P 1 by G 1 plus P 2 by G 2 plus P 3 by G 3, where P 1, P 2 and P 3 percentage of weight of coarse aggregate, fine aggregate and feeler respectively. Now, G 1, G 2, G 3 bulk specific gravity of coarse aggregate, fine aggregate and the feeler respectively. Now, bulk specific gravity of compacted bituminous mix, this is the bulk specific gravity of bulk compacted, the weight of a specimen in air divided by weight of a specimen in air minus weight of a specimen in water. So, the total volume of the mix will be V Vg plus Vb plus Va. So, this will be equal to Wg divided by bulk specific gravity of the aggregate plus Wg by Gb plus Va. This is the total volume of the mix, and see here, this is the any mix have air voids part, bitumen part and aggregate part. So, this is the total weight. Of course, air has no weight. So, this is the Wb means weight of the bitumen, and this is Wg weight of the aggregate. So, this is the total volume. Is it? So, now this is the volume of air voids, now volume of bitumen and volume of mineral aggregate. So, this on this side this is the weight and this side this is the volume. Now, come to the this diagram, this is systematic diagram of individual aggregate showing air voids and absorbed bitumen. What happened? This is the aggregate mass and there is a absorbed bitumen in this slot. slot of the aggregates, right? But the bitumen is not completely go inside this aggregate mass. So, some part of the air will be available as a air void in the aggregate. This is a aggregate bitumen. So, and these are the air voids here, you see here. So, this is the cross section of a bituminous mix obtained from the image analysis. Now, again come to the our previous calculations. If the specimen consists of porous surface, then what happens? It may absorb water. When it is measured in water, to avoid absorption of water, the specimen is coated with the paraffin or the wax. So, then the bulk density of the wax coated specimen G bulk wax is weight of specimen divided by weight of wax in air minus weight of wax minus water minus weight of wax by specific gravity of the wax. So, here W specific W SPC is a weight of a specimen in air, W wax air weight of wax coated in a specimen in air, W wax water weight of wax coated in the specimen in the air. Now, weight of wax coated in the air, that is W wax air minus W specimen, and G wax is the specific gravity of the wax. Now, void present in the mix in the percentage 100 V A divided by total V means total volume. So, here V A will be equal to V minus V G minus V B. Here V is the total volume of the specimen, V G is the volume of the 3 mineral aggregates, means coarse aggregates, fine aggregates and the finer. V B is the volume of the bitumen. Voids in the mineral aggregates, V M A in percentage 100 minus V G in percentage. Is it? So, here V G in percentage percent of volume occupied by total mineral aggregate, and this will be equal to V G percentage will be equal to P 1 plus P 2 plus P 3 multiplied by G bulk combined divided by G bulk aggregate. Now, void filled with the bitumen V F B in percentage 100 into V B percent divided by total volume. So, the bitumen percentage volume of the bitumen in percentage is equal to percentage of bitumen into a specific gravity combined divided by G B, a specific gravity of the bitumen. The volume of the bitumen absorbed by the aggregate due to the presence of force on the aggregate surface. So, V A B 100 into 1 by G bulk aggregate minus 1 by G S C into V B. So, here G S C is the effective specific gravity of the mineral aggregate, G S C is a 100 minus percentage of the bitumen and 100 by a specific gravity minus percent of bitumen divided by a specific gravity of the bitumen. So, G M is the maximum specific gravity of the mix without air voids according to ASTMD. So, this is the volumetric analysis and it is a rational method we can calculate it and then we can mix the aggregates. The next is Marshall mix method, and Marshall mix method is widely used in India. It is developed by Bruce Marshall in 1940 in USA, used to determine the optimum bitumen content which satisfy a given design criteria of stability, deformation or flow, density, minimum air voids, void criteria and VB, volume of filled bitumen of hot mix mineral aggregate and the bitumen under the standard test condition. Then how to prepare the specimen? In number of specimen by changing proportion of bitumen at increment of 0.5% by weight with the selected grade of the aggregate. Sample whose maximum size is restricted to 25 mm of 1200 gram. Total weight of the sample is 1200 gram and the maximum size of the aggregate is 25 mm. Now, mineral aggregates are heated 154 to 160 degree centigrade, bitumen is heated 175 to 190 degree centigrade, quantity measured by weight of the mix. Now, bitumen viscosity during mixing is 170 plus minus 20 centi stroke. Mix placed in the cylindrical mold of dia 102 mm and depth 64 mm. Mold is heated 93 to 149 degree centigrade. The compacted 75 blow of the standard hammer, means total mix is compacted by 25 blows of a standard hammer. The bitumen viscosity during the compaction should be 28 plus 2800 plus minus 30 centi stroke. The specimen allowed to cool at room temperature for 12 hours and kept in water bath at 60 degree for 30 minutes. The test on the prepared specimen is placed diametrically. This is the diametrically placed here diametrically. In the test setup, load is applied vertically on the specimen at a constant rate 5 centimeter per minute. Load is applied from this is the loading applied system here. The maximum load at failure is taken as stability. Corresponding deformation value often from the dial gauge is taken as the flow value. So, this is the setup of Marshall stability test. This is the gauge, this is the deformation gauge, means dial gauge by which we can calculate the deformation, and this is the probing ring where 50 kilonewton have a capacity. These are the presentation of test data and interpretation of the curve. So, this is the unit weight versus percent of the bitumen by weight mix. This is the curve, and see here as bitumen earlier the bitumen percentage is increasing, the unit weight is also increasing, but at a certain point when increase in the bitumen percentage, then the unit weight of the mix will go on decreasing, because the if the quantity of bitumen is more, then the aggregate will flow inside the mix. So, this will decrease the unit weight. Second is percent air voids by percent bitumen by weight mix. Here see here as it go on decreasing, when bitumen quantity is increasing, the air voids is decreasing of course. The third is a volume of mineral aggregate, as earlier when the bitumen is increasing, then the this volume will decrease, but again this will go on increasing. The next is void filled with the bitumen with percentage, it is go on increasing, and then the Marshall stability means flow value means strength, it will go on increase, and then after increasing the content of the bitumen, the Marshall stability will go on decreasing. This is the flow value and the bitumen by weight of the mix, this will go on increasing. These are the standard fixed by the design required for the hot mix with the modified bitumen. So, these are the parameters for requirement: hot climate, cold climate, high rainfall, and test method by which the test could be followed. So, these are the chart. We have to receive these requirements while designing the piping mix. So, this is all about this thing. Thank you very much.